Hello and welcome back to Calero Academy. Today we'll be doing a very interesting question from the 5th edition of the book Introduction to Mathematical Statistics by Robert V. Hogg and Alan T. Craig. The question, 2.26, states, let there be a correlation coefficient ρ of the random variables x and y. Then show that the random variable ρ is between -1 and 1. This question is very interesting, not only because it helps us practice our theorem proving skills, it also is helpful because of the hint. The hint says, consider the discriminant of the non-negative quadratic function h of v is equal to the expectation of, in brackets, x minus mu sub x plus v times y minus mu of y, all squared, where v is not a function of x nor of y. Note that mu of y and mu of x are just the means of y and x. So, this is a very interesting problem. I'm going to break it into 2 videos. The first video will be proving it using the hint that they gave us. And the second video will try to prove that the correlation coefficient is between -1 and 1 by proving it from basic principles. So, first let's put it in theorem format to prove with the hint. Want to show that -1 is less than or equal to ρ, which is less than or equal to 1. Proof. The discriminant is equal to, DISCR, is equal to b squared minus 4ac. Where a, b, and c are coefficients in the quadratic equation, for some quadratic equation f of x is equal to ax squared plus bx plus c. We want to get h of v into that form and prove from there, so we can get the discriminant. So first we're going to expand, and we're going to have h of v equals the expectation of, in brackets, x minus mu x squared plus 2 times v times, in brackets, x minus mu x times y minus mu y plus v squared times, in brackets, y minus mu y squared. Okay, now let's try to expand the part in the middle bit. Writing with more space, we have h of v is equal to the expectation of x minus mu of x, all squared, plus 2v times x times y minus 2 times v times x times the mean of y minus 2 times v times y times the mean of x plus 2v times the mean of x times the mean of y plus v squared times y minus the mean of y squared. So, the expectation of something is a linear operator, which means that you can break apart this beast into the addition of many little expectations. So we can write h of v is equal to the expectation of x minus mu x squared, all squared, plus 2v times the expectation of x times y minus 2v times the mean of y times the expectation of x minus 2v times the mean of x times the expectation of y plus 2v times the mean of x times the mean of y plus v squared outside of y minus the mean of y squared. Expectation of that, sorry. So, let's try to simplify this equation. Remember that the variance of something is equal to this. The variance of x is equal to the expectation of cap x minus the mean of x all squared. So, we can write h of v is equal to variance of x plus 2v times the expectation of x times y minus 2 times v times the expectation, times the mean of y times the mean of x, because the expectation of x is simply the mean of x, mu x, minus 2v times the mean of x times the mean of y, plus 2v times the mean of x times the mean of y. Notice that these two will cancel. Plus v squared times the expectation, times the variance of y. We can simplify that too. So, now, writing and cancelling that out, we have h of v is equal to the variance of x plus 2v times the expectation of x times y minus 2v times the mean of x times the mean of y plus v squared times the variance of y. Now we can try to write this h of v in the form of ax squared plus bx plus c. Let's group together the v squared, the v's, and the constants. So we have h of v is equal to the variance of y outside of v squared plus 2, in brackets, times the expectation of xy minus 2 times the mean of y times the mean of x times v, all times v, plus the variance of x. Therefore, we have that the constants a, b, and c correlate to a is equal to the variance of y, that b is equal to this dog's breakfast here, and that c, the constant, is equal to the variance of x. Now we can try to find out the discriminant of h of e. But before we go on, we must note that because the hint told us that the discriminant of h of e was non-negative, therefore the discriminant must be less than or equal to 0. So you have the discriminant of h of e less than or equal to 0, because h of e is non-negative. Okay, now the discriminant of h of v is equal to b squared minus 4ac. So b is equal to this, so we have b squared 2 times expectation of y times x minus 2 times the mean of y times the mean of x, all squared, minus 4ac, 4 minus 4 times the variance of y times the variance of x, minus 4 times var x times var y, which is all less than or equal to 0. So, adding 4 times the variance of x times the variance of y to both sides, we have 2 times the expectation of x times y minus 2 times the mean of y times the mean of x, all squared, is less than or equal to 4 times the variance of x times the variance of y. Now, we have to be careful here. The obvious thing that we should do next is take the square root of both sides. But we have to remember that on the left-hand side, that will result in there being 2 things, because the square root of this is equal to that, let's just call it this, is equal to both 2 times the expectation of x times the expectation of 2 times the expectation of x times y minus 2 times the mean of y times the mean of x, and also it's also equal to minus 2 times the expectation of x times y plus 2 times the mean of y times the mean of x. So we'll have to break it into 2 parts when we take the square root. First, we're going to be dealing with the positive one, and we're going to have that 2 times the expectation of x times y minus 2 times the mean of x times the mean of y is going to be less than or equal to 2 times the standard deviation of x times the standard deviation of y, since the standard deviation is just the square root of the variance. So, dividing both sides, we have the expectation of x times y minus 2 times the mean of x times the mean of y, all divided by, minus the mean of x minus the mean of x times the mean of y, divided by the standard deviation of x times the standard deviation of y is less than or equal to 1. Remember that the covariance is just equal to that, the expectation of x times y minus the mean of x times the mean of y. So we can write that the covariance of x and y divided by the mean of x, the standard deviation of x times the standard deviation of y is less than or equal to 1. But remember, the correlation coefficient by definition is equal to this. So we have the correlation coefficient is less than or equal to 1. Let's not forget the second side of the story, the negative square root. So now we're going to have to do it for this one. So we have, starting back from the beginning, we have that minus 2 times the expectation of x times y plus 2 times the mean of y times the mean of x is less than or equal to 2 standard deviation of x times the standard deviation of y. Now, divide both sides by the right-hand side, and we have minus expectation of x times y plus the mean of y times the mean of x, all divided by the standard deviations of x and y is less than or equal to 1. Let's multiply both sides by minus 1, and we get, switching the inequality sign, we have e, the expectation of x times y, minus the mean of y times the mean of x, divided by the standard deviation of x and y, is more than or equal to minus 1. But remember, the left-hand side is simply equal to the correlation coefficient. And now we've shown that the correlation coefficient is both less than or equal to 1 and more than or equal to minus 1. So we have minus 1 is less than or equal to rho, which is less than or equal to 1. We've done it, and we can write the success box. Thank you for watching, and I hope you come back for more. Goodbye, and this has been a